Hey guys, welcome to the session by Intellipaat. As we all know, Python has an abundance of rich libraries, one of which is Matplotlib. It is one of the most popular visualization and plotting library for Python. In this video, we are going to learn how to create visualization using library in order to create valuable insights from your dataset. So before moving on to the session, please subscribe to our channel so that you will never miss an update on our upcoming video. Now let's have a quick look at the agenda. First of all, we will learn what exactly is Matplotlib, and then we will see why do we use Matplotlib, and then we will go through some of the different types of plots in details. And finally, we will have a quiz in order to recap what you have learned, and also comment your answers in the comment section. And also guys, if you want to master data visualization using Python, please check out the data science using Python certification course offered by Intellipaat. Now let's get started.
2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name, that's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on numpy, so numpy is also possible. I have shown you examples, but this matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib, and how that can be used, and what are the usage of those graphs, and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used the alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is. Next, what we are gonna see is what are the different types of plot that we have. Before that, let me come to this inline thing. So this inline function, if you don't have it, it will still work. Okay, this percentage matplotlib inline, you won't see a difference in Jupyter notebook. Okay, because this Jupyter notebook is anyways browser based, right? So this won't give you any difference when you use Matplotlib from any web based or any kind of notebook kind of scenario. Okay, but if we have a different set of, if you are running Python separately, right? If you are running Python separately, correct, using Spider, it can be Spider, it can be a simple command prompt of Python, anything can be there. So if you are running it from those, IntelliJ idea means PyCharm. Okay, for Python the ID name is PyCharm.
A quick info guys, if you want to master data visualization using Python, please check out the data science using Python certification course offered by Intellipaat. You can find the link mentioned in the description. Now let's get back to the session.
So if you are running using those IDs, or if you are running using like what, let's say if you are running it from the command prompt, then this will create a separate window. So that's where it gets difficult. Okay, so that's where it gets it is, I mean, it is advisable to use this like numpy, I mean, sorry, this matplotlib inline command for having the graphs inlined to the screen that you are currently using. Okay, otherwise what it will do, it will create you a whole separate thing. Okay, so it will give you a different set of, I mean, a different window where you will see the plot. So that's why we use this matplotlib inline. So that's the basic standard, to have it displayed in the same window. Okay, so that is why we use matplotlib inline. But if you don't want it, if you want the separate window to pop up, it will also work. Okay, that will also work. So that's not need to be worried. Okay, before that, let me show you what are the different types of plot that we are having in Matplotlib, and what are their uses. Okay, then we will go to each of the examples one by one. So if the what you need to remember from this whole lecture will be two three things. Okay, first of all, why and what plot need to be used, where it need to be used, and how you can write those. Okay, customization, even if you learn it slowly by playing with it, it's perfectly fine. I don't That's not a matter. Okay, the customization thing, coloring thing, changing the axis labels, adding legends, changing the colors, there can be thousands kind of customization in Matplotlib. Okay, so do I have that mail with me? No, I will have it my official email ID. Okay, so what I did, for some requirement I created, there is some kind of graphs and charts that goes to higher management. Okay, for reporting purpose, that goes every day. Okay, so I created something using Python, no data sciences involved, that's a straightforward thing, much easier. So I created a simple script or simple job using Python. What it does, it takes in data from a rdbms, it plots the data nicely in a matplotlib plot, and it sends it to you, sends it to the upper management. So when I am telling upper management, that is D plus. Okay, so that's where this comes handy. So and there you understand, right? When we are going to show this to upper managements, we need to have the graphs beautiful, we need to have all the specifications, we need to have pointers, we need to place them in the right position so that they don't find any errors and they won't accept anything so easily, right? So that's how powerful Matplotlib library is. I don't have the I can't show you that because that's not allowable. So otherwise I would have shown you. So that's how you can do it. So the graph, what I can do, like the simple graphs that you are seeing in here, you can change the background color of the graph. Okay, so the background will be of some different color and the foreground will be of some different color. As you are seeing there in the right hand side, we have a bar plot, right? In the bar you can choose each and every bar color one by one. Okay, that can also be done. All these bar objects can be accessed individually. Okay, once you plot these bars in Matplotlib, right, all these individual bars can be accessed one by one. You can change their width, you can change their height, you can change their color, you can set text to them, you can write text in between them. So whatever you can do in Excel with all these graphs, the same things can be done in Matplotlib. But again, those things are not required for your day-to-day work. It will require me very rarely. So if even if you don't understand those, if you even if you like the Anascom quartet I have shown you, if I start explaining the whole graph, it will take the entire class because it has too much customization in it. Okay, So just to keep it short, and just to give you the proper idea so that you can start experimenting or playing with it, the basics I will tell you. Okay, and on the basic you can build up. Okay, you can build up on the basic. If you do understand the core concept, you can easily build up. So, and also if you are facing any problem, you can tell me in the next class also, I can help you. Okay, so that's how powerful Matplotlib is. And let's see what kind of graphs we use. We have line plots. So line plots, what we use just to plot 2D equations, right, with x and y. There we will use line plots. Okay, so line plot will give you a trend line in an equation. Okay, so when we see linear regression, we will see its use pretty heavily. Okay, for machine learning, and also for observing a data set how it is distributed. This is really needed. Okay, next is bar plot. This is the same as line plot. The difference between these two is you can add a trend line in bar plot also, so that way it will become this, but this denotes the area covered by the point. Okay, so the bar will start from x-axis and it will go, the height of the bar will equal to its y value, and the shaded area will be showing the area covered by that point. Okay, so that's where bar plot is needed. Bar plot is basically this, it is required in the same way we have line plots. So what is different in here? In line plots you might not be able to tell what is the value of x for the value of y at x equals 17.5. You need to go there, you need to see, it will be difficult for you. But in bar plot you can see it there directly, right, because the bar will do that. Significance of width, there is not much, it is just to illustrate. Okay, illustrate this bar one. Okay, this is that is how this bar is designed. So bar means it will show you some area covered by the curve. So if you calculate this rectangle, so what it has, this rectangle is same, this rectangle has this width of some x value, height of this y value, right? So if you calculate a rectangle covering that area, so this will denote the area covered by that point. Okay, by that x and y point, from the ending to beginning, this area will be covered. So area is shown here. Next is scatter plot. So scatter plot and line plot again are same, but only difference, the points are not joined. So you need to understand when we use these two. When we have a continuous set of data, we know that it might fit a linear equation, right? It Yes, Azam, I just explained it. What is the significance of the area, right? So in the line plot, if you have like if you have a what like continuous set of data, then in that case this line plot will be visible. But if you don't have a continuous set, if you have some chunk of data, clusters of data, then you will use scatter plot. This is to see the data distribution, how they are distributed, and this is the trend line of the data. This example of scatter plot you will see when we are covering clustering. You can understand, right? We have seen some clustering algorithms. So if you plot the data in this plane, then from that you can easily understand how many clusters will be formed from that k-means, right? The k value you can find it from your you can find it by checking that manually only, right? If you plot the data, it will be clear to you. After clearing the data, if you are able to plot that data in this plot, you can find the value of k without any hack, right? And you can pass it to the algorithm to give you those many clusters and their centroids and all. But what you not need to do is you no need to check the data points and decide which point will be belonging to which cluster. Those things you no need to calculate. Okay, next is this histogram. Histogram is basically used for image processing purpose. This histogram shows you basically, okay, so this histogram is basically used for like image processing purposes. And what this bins are denoting, this bins denotes the number of times the values, the frequency of the values, the frequency of each point occurring in the data set. Okay,
A quick info guys, if you want to master data visualization using Python, please check out the data science using Python certification course offered by Intellipaat. You can find the link mentioned in the description. Now let's get back to the session.
so that's what this bins are denoting. So this is not really used in data science, somewhat used, but it won't fit our purpose always. So maximum for image processing this is used. to see how the data is spread and what are the frequency of the data point that we have, what are the frequency of pixels that we have, those kind of cases, and histograms comes handy. I will show you all these examples, but again this is not really required. Image plot, again, this can yeah, CPU processing is also histogram, right? So that's what. So wherever the scenario fits in, to show you some frequency kind of thing, wherever it fits in, then you can use histogram. Okay, wherever you need to find out some frequency of some point in dataset. Let's say for CPU processing, if you see the graph how it will look, it will give you how much CPU is used in what point of time and what is the frequency of high CPU uses. In that case, they will use histogram because it will give you the frequency related data. Okay, difference between bar and histogram is bar plot won't give you this frequency, it will just plot the x and y points. It is almost similar to the trend line, except it will show you the area, it won't show you the frequency. But from histogram you can find out the frequency. When we go to example, let's see how we can do that. Okay. Okay, next is image plot, right? Image plot is to plot some image. Okay, again you won't need that. So image plot will fit in a existing image to this to the 2D plot, and it will show you the height and width and all those things you can see visually. Okay, next two plots are really important for us. Those are box plots and violin plots. Okay, so let's do one thing. Let's see the examples of all the 5 plots that we discussed, then we will discuss the rest 5. Okay, rest 5 or 6 whatever we have, we will discuss those after that. Okay, let's see these examples first. So this line example I have already shown you. Now the next one is how to customize these lines. So basically these are the basic customization technique I will show you. So see here what we have done. We have taken the same example as the earlier one, just we have reduced the number of points. We have used this fig equals plt dot figure, fig size equals 10,5. So this plt dot figure object, what it does, so if you don't use it, that also work, but how it works is this plane is a single plot. Within the plot you can create multiple figures. So let's say you want to create two charts side by side. In that case you will use this figure. Okay, you will create a figure size, I mean you will create this 2D plane first. Okay, then you will plot this line. That is the best standard practice, so you should follow that. Okay, you will create a figure object, then you will plot the data points. Okay, that is the standard that we do. So how do we do that? What we do, we use plt.plot function as shown before. We are having x and y, two values for x and y data points. Next we are passing is this line width parameter, right? So this is to provide that line width, what it will be. Next is line style. It has many different line styles also. It has dash, you can give 0, you can give o, any character you can give. Let's say I am giving I, and if I run it, it won't run because I is not a supported character. What was that supported one? I don't remember. I think dash was supported. Yeah, so this line style you can provide anything. Okay, sorry, not line style. Line style will be dot dash, these two things only, or a continuous line. I was talking about this marker. Marker you can put anything. Okay, so marker you can put something like this also. Unrecognized marker. Marker, except to what we had cross, I believe. We had cross, yeah, we have plus, those kind of markers are there. So this marker object is to show you this points. Okay, show you this data points, how you want to see those, but o gives you the best visualization among all. Okay, so that's how you can use it. Okay, next is this line style is for styling these lines, this intermediate lines. If you provide colon, then it will be like this dashed line. If you provide a dash, dashes will join, right? So dashes will join, and you will see a straight line. So that's how this works. Next is color. You can provide any color. You can write the full name also. You can use the short name also. You can provide here the RGB values. You can provide. Let me show you. You can provide this hex values also. You can do anything. Okay, let me take the default color that is coming. So I will show you this to example. Come on. Okay, if I tell it take it this, and if I put it here, this will also work. Okay, see the lines have changed to blue, right? If I provide this, that will also work. I don't remember the syntax for RGB. RGB is not much used, but still, okay, sorry. But still you can provide like this, I believe. And RGB like this. No, RGB is not the thing. RGBA, how was it? How was it? I don't remember. Okay, RGB styling in Matplotlib. Just let me check it. Check in Google. I will show you. Just a second. RGB, anyways, we don't use it much. We use the simple names or hex codes, because hex codes you can find in many places. Like like in net, you can have it easily available. You can create your own colors. But RGB we really don't use in plot. Yeah, so that's how. So I will still show you because it can be done. So I believe we can only mention the tuple. We no need to write anything in behind. Let's see. Still it doesn't work. Why? How to give it? Just the tuple without this single quotes? I believe yes. Let's see how it works. Still not working. Okay, how do I give it? How do I give it? Why it is not working? Not sure. It should work like this. Somewhere it is not working somehow. Not sure. I will check in the break and I will tell you. Okay. This one I will tell you. So you can provide the hex value or you can provide the mnemonics also. You can type in any color in full also. If I type it yellow, it will also work. Okay. So that's how you can use this color attribute for all the graphs. For all the graphs you can use it. Okay. So you can type in any color or you can provide the hex codes also. Okay. So let me give some good color here. So that's how it works. Okay, that's how this color attribute works. Next is for alpha. Okay, alpha is for reducing the brightness. Okay, reducing the I mean the transparency of it. Let me give it blue. That would look the best. So that's how. So alpha is the transparency. Okay, alpha is the transparency of it. Yeah, that is not working, Nancy. I also remembered the same thing. RGB is not working. RGB and nothing is working. So I will check and tell you, no issues. Okay, next is alpha is for reducing the brightness. So let's say you will understand on your own only. I no need to explain. If I run it to 1, see this is much vivid. But if I do it 0.1, you will see this is way too dim. It will be way too dim, right? So that is what is alpha. Alpha is for reducing the brightness. So alpha is the transparency factor. So if you reduce the alpha, then what it will do, it will make the line or plot whatever you are doing transparent to the plane. So it will match the background color of it. Almost it will match the background color of it. It will be a very fade color. But if you pick a high alpha value, it will give you somewhat deep lines. Okay, you will see the dark lines, dark colors over there. Okay, so that's what is alpha used. Marker, as I have shown, these points are called markers. So that's how we plot a line. Next is this title object, right? This title function. So what we do with this title, we plot this title like line plot demo. This we put it using this plt.title and it will automatically be placed here. Okay, it will automatically be placed at the top. You can change it to bottom also. You have options for that, but the basic that we follow, the standard, that is to put it in top always. And x level, y level, x axis, y axis, you can type it. So the labels, axis will be labels. Okay, axis will are labels. It is not for the value, it is for the labels only. Okay, that's how it is. And for the limit of it, the graph will take on its own. It is best to leave it on its own. because it will be helpful. Because if you are trying to manipulate the graph, because see, you will always not know this, right, that how much data you are covering, how much data you are taking, like that. So that's why this is best to leave it on the graph itself.
A quick info guys, if you want to master data visualization using Python, please check out the data science using Python certification course offered by Intellipaat. You can find the link mentioned in the description. Now let's get back to the session.
So it will decide the best min x min y, min x min y, and max x max y, and it will plot it. Okay, so that's how it works. Okay, next is for plotting legends. Legends means this small markers. So to show you, to show someone which one line denotes what, right? That is what is legend. So for plotting legend, what we do, we use this legend function. Okay, we use this legend function, then within bracket we line the marker name. It can be a list also. Okay, it can be a list. If we had two lines here, let me show you. That will also work. Let's say I have an orange object now with marker as cross. Okay, and it is darker. Let's make it darker. And if I run now, you see we have two lines now in the same plot, right? So how you can have here, you can write like this, and see everything will be taken care automatically. Okay, see here, in legend it's already added, the my line thing is already added, and LOC equals base means the graph will on its own calculate the best position for the legend, and it will put it. So it will always put in the best position. It can be down, it can be up, it can be anywhere. Okay, plt.grid true, that is to show these grid lines. If you don't want it, just don't mention this function, it won't show you these grids. Okay, so that's up to you. If you like the grids, you can keep it. If you don't, you cannot. So there is no really no real thing in that, in showing or not showing the grids. Okay, somewhere if you fill it, you can provide you can have those displayed. Okay, so that's how this grid works. And plt.show, as you know, to show the plot, to show the to, I mean to display the plot in front. So that's how this thing works, this line plot works. Okay, okay, so that is what is about line plot. And you have seen only single line plot in a picture, right? So I have shown you two line plots in the same graph, right? Let's say we have two different plots in the same we have two different subplots in the same plot object. How do we do it? Okay, so that is where this subplot function comes into picture. That is where this subplot function comes into picture. So if you see carefully what we have done here, we have taken the same thing, the same functions that we used in the earlier example, and we have shown you this. We have shown here the two different plots in the same thing. Okay, we have shown two different plots in the same figure. So that's how. Okay, so the next thing is the parameters that we have passed, and how do we create this subplot. Okay, so how do we do is, firstly what we did, we used plt.subplot function. Okay, so subplot function, we have, there are many parameters that can be passed on to it. Okay, there can be many parameter. So we have provided only three parameters here. This is just to have it in a standard one. Okay, so how does it work? Okay, that means the first one, two, right? These are for number of rows and number of columns. Okay, so we have created one number of row and two number of columns. Why one number of row? Because we want this to have in a single subplot, right? We want this to have in a single plot. So see, when I change it in two rows, so this first one gets smaller, right? Because it has created two rows. First one contains the first graph, second one contains the extra portion of the second graph. So always try to have n rows as one if you don't want to create more rows. Okay, so sorry, for the first subplot, for this first subplot, if you create two rows, then the same area will be divided into two parts, so the graph became smaller in and got fit into one row, and the next row is left around. Okay, so that's how it is created two rows here. So here, so the idea is, if you want to fit two graphs in the same subplot, then only go for this 2 1. Okay, but standard is to use one, because we generally, when we subplot it, we want the subplots to contain one graph. If you want to fit in two graphs like this, you can create a separate subplot here and you can plot the graphs. Okay, so that's how this plt dot subplot is used. See here, we have passed in number of rows and number of where we have passed in only plt dot subplot, we have passed in some integer numbers. Plt dot subplot 221 222, so these are just integer numbers, right? So this is 221, this is 222, the starting point of the subplot, and the plot will adjust on its own. This is also an expression that we use, but this is not standard. Okay, this is not standard. This is just to have four plots, four plots arranged in a rectangular way. The standard is always this one. So we pass the number of rows, number of columns that we want, and this one is for number. So that means how many figures are there. Okay, how many figures are there. So this thing, the pyplot.figure function that I have shown you in the in the earlier part, that will be called, and the figure number will be attached to it. That means this is figure number 1 and this is figure number 2. Okay, so if you want to customize it using this figure object, then you will see how you can use it, but that is not really required. Okay, for now, just know that this is a number parameter that is being passed into this function, and that denotes how many number of, what is the figure number that is there in the graph. Okay, so for the next one, if you see, we have created the same subplot size 1 2, and we have provided number equals 2, so that means this is a figure 2. So this is figure 1, this is figure 2. Okay, the rest functions the same as what we had in this. So plt dot title, it has plotted these titles of graph 1 and graph 2. Plt dot show showed you the graph, and plt dot plot show plotted this x and y1 and x and y2, these two things. Okay, so that's how now line plots can be created and customized, and also multiple line plots can be created in the same subplot. So this applies to all the other graphs that we are going to see. So we won't show you those in that much detail, but you can always create a subplot. You can fit in two bar plots, two line plots, two scatter plots, anything you want in there. Okay,
Number of
so
columns. Number of columns means like one on x-axis and one on y-axis, or what? How?
no, number of columns will denote the width of it. Okay, the height and width, these two things. So if I give it one, it is so small that it just went out. So that means if you want to divide this, right, how many columns you want in the figure. Okay, so so we want two graphs to be displayed, so that's why we set it 2. If we do it 3, that means we have a provision for the third graph to be displayed, and see, this graph is smaller, right? So if you change it to 3, it will be smaller, because it is providing you option for creating a third graph here. So the entire figure, how many columns are there, so that's how it denotes. Okay, so that's how it denotes. So if you do it one, only one graph will be displayed. Okay, so that's how it works. Okay, so that's how you can create this subplots. So is this clear? Then we can move on to this bar plot. Okay, so bar plot is basically to show you some counts, to show you some this is basically used to show you counts. Okay, so see here what we have done. We have created a data set with three this is a dictionary, right? So we have count for apple, mangoes, lemons and oranges. Okay, for x-axis we have taken the dictionary, the list of keys from the dictionary, and for the y-axis we have taken the list of values, that is the count for those. Again, we have created a figure size. How do we plot a bar chart? We plot a bar chart using plt.bar. We passed in x and y. This kind of nice little rectangles are shown over here. So this is 15 and this is the area behind this curve. So next we will see how can we change the width and all of this curve. Okay, so let's go to this one. See here, this is actually this like horizontal bar graph. Okay, so here for horizontal bar graph we have taken the same data set, we have used bar each function, right? So bar each and bar both will have the same kind of customization. This width will be decided on its own, you no need to specify that. Again, as I told, you can change it, height and width you can change, but that is way too advanced. Take your time, you can work on those things later only. Okay, so this can be done. Just you, if someone asks in the interview, just tell them yes, we can customize those, it is not by default. But how this is, that is a really advanced topic, I don't think interviewers will know also. Okay, next is data. How do we create horizontal bar chart? This is a reverse bar chart. So here we can have bar each function to be called for the plot, and similarly we pass in the arguments. Now the next thing to be covered is like bar and bar chart customization will be same as both will be same. So here beside this I can provide the colors also. Okay, so colors, let me put, say what should I put, let's say I put maroon. So next one I will make it green. So that's how it looks. Okay, so you can pass in the color object, color at color parameter to it, and these bars will be colored according to that. Okay, so similarly for bar and bar each, same things will be applied. And this plt dot title, x label, y label, we have already seen, right, when we covered this line plot. So similarly those can be plotted. So see here, bar graph demo, quantity, fruits. Here also you can put it in the similar way, you can put it in this way. Let me show you, copy is not enabled file. So the similarly you can do for bar and bar each. So remember, bar is for plotting bar, bar each for plotting horizontal bars. Okay, so that's how bar plot looks like. Okay, so that's how bar plot looks like. Now next, any doubts in this, or scatter plot is fine now? So now we will go to the scatter plot. Okay, so scatter plot, see, scatter plot is a bit different, it is not like x and y equation. So we have three data sets, a, b and x. So this is x and y equation actually. So for this x value, this is y value for one, so let's consider this as x and y, and consider this as x and y1. Okay, so no equation we need to do. What we can do, we can just generally point these things. Okay, we can just distribute the points over the plot. Okay, so that's how we did. Okay, and this points will be taken automatically. Okay, the colors will be taken automatically. So next we will see how can we customize it. Okay, these are the basic customization techniques, not advanced. Many things can be done with it, just remember that. Okay, so again I will change it tomorrow. Okay, so here, okay, next thing to be show you is for line plot we use plt dot plot, right? For scatter plot we use plt dot scatter. We pass the x and y arguments inside this scatter, and then we get this nice looking output. Okay, next is customizing scatter plot. Same equations we have taken. So this c, either you can write c or you can write color, anyway it fits you. Okay, s is for size, that means size of these things. If you make it, let me add another 0 and run it. So it will bigger the size of the data points that you have. So size, that is really size, you can write a whole or you can mention the short name, anyways it will work. Okay, edge colors means if you see these lines carefully, the edge is colored as yellow. Okay, because so edge is colored as yellow. So for, if I do it black, you will see that, I believe it is really hard to see here. If I make it one, I think you can see. Yeah, now see, the green round objects are covered by a black border, right? So that is the edge colors to differentiate between 1 and 2. Marker, it can be different kind of things. So marker have 0, o 1, if we give, it will give you some this kind of downwards value. 2, if you give, it will give you some upper kind of values. For 3 you will have the in the reverse side, okay, in the reverse arrow, and 4 you already have it, right? Or if you put O, it will be the round objects that is getting that is going to be put. Marker can we customize? No, we cannot. Okay, so these are the choices for the marker object. Alpha, as we discussed earlier, alpha is for the same thing. Okay, alpha is for the same thing, to reduce the brightness of it. Okay, next is plt.legend title x level y level, same as others. plt.grid, same as others. So now if you see, we have a plt.savefig scatterplot.png. So this is to save the output of the curve that we discussed earlier, right? This is to save the output of it. So if I go back to my Jupyter notebook, see here scatterplot.png is saved, and if you open this graph picture, you can see, and then you can use it for your own purpose. You can attach it in mail, you can send it, or you can do whatever with this. Okay, so that's how you can save the figure to a nice looking image. So that the command for this is savefig, plt.savefig. Okay, so plt.savefig, that's how it works. So that's what is with scatter plot. And now next is this histogram. Okay, so is that clear? Next is histogram. So histogram is to show you counts for some numbers. So we have taken a huge data set to show you this counts. Okay, and we have created the histogram using plt.hist function. Okay, next we have passed in the array that we need to plot in histogram, and we have passed in this bins, right? So bins means where these markers will be put in. This is again intuitional, you can put it anywhere you like. So these are the markers, the marker points. So 0, 20, 40, 60, 80, 100, like that we have given. So how to, yeah, bins are intervals only, correct? So how to understand this histogram? So can you check the data? If you check the data set and if you see how many points are there between 0 and 20, 1, 2, 3, 4, 5, 6, 6, right? So if you check this, so 20 we have 1, leave it. So till until 20 we have 5 points, right? If you check from 0 to 20, what is the value? What is the y value? 5, right? For 20, so from 20 to 40, if you count, we will have 7 values, so it will be going up to 7. Okay, 40 to 60, it is really small, right? Only 1. So see here, the height of histogram shows you 1, right? 60 to 80, if you count most of the numbers, so 68, 64, 62, 60, 70, 78, 75, 79, and all those numbers. So almost 6 7 numbers, 7 numbers almost. So if you check, or 8 numbers, whatever, so you will see 8. Okay, 80 to 100, 3. So 3. That's how to understand histograms. Okay, that's how you need to understand histograms. So that's what histogram denotes. Histogram denotes the frequency of data points between a range. So from 0 to 20, how many? 22. So what happens if we add another bin, right? The graph shape will change radically. Why that will change? Because within 0 and 10 we don't have any point, so it has kept it blank, so we haven't put the marker over there. Now let's say we are plotting a marker in 30. Okay, we are changing this to 30. So see it, from 20 to 30 the bin has changed, right? Because we have created two different markers. So 20 to 30 we have a dip, right? We have a dip. So within 20 and 30 we have 3 points, and 30 and 40 we have 4 points, like that. So that's why between 20 and 40 we have total number of 7 points. Okay, that's how to understand this bins attribute, and that's how to explain a histogram to someone. Yes, right, it will be changing with data, correct? Okay, so this is to color the histogram. We, yeah, so that's what I'm telling, right? So that's what I told earlier only, right? Before starting with the examples, bar you will see when you just need to, when you have the counts of some data points, you need to display those in a graph. So that's why you, when you use bar, linear equations, when fits into scenario, you use line. When you want to see the distribution of data over a plane, you use scatter. And when for image processing kind of thing, and when you need to find out counts of data points, you use histogram, right? You don't know the counts, you want to find out without writing a code, you can, if you plot a histogram, you will have the count. So that I told when I covered the theory part of it, right? Okay, next is customizing histograms. Again, we have provided this bin numbers. Age color we have provided as black, and color we have provided this funky red color. Okay, title, X level, Y level, grid, sefig, already you know this, right? So same thing, not wasting much of a time. So age color and color, we can do it in all the graphs, and we can customize the graphs. Okay, so that's how this works. That's how this histogram works. Okay. Okay, so that's what we discussed till now. Image plot is not really required. We are not so for now I am skipping it. It's not really required. Do I have it? No, I don't have it. So any images can be plotted into it. Okay, so that much you can remember. So that will be enough for you. Okay, so that's how it is. Okay, so that's what we have till now. So next we will discover box plots and violin plots. So let's have a 20 minutes break and come back. We have a lot of theories in mind. So then we will discuss this. Okay. So box plots and violin plots are hugely used. I will tell you when and where to use it. So any doubts till this bar plot, or is it okay? We can go for a break and then come back and go for this box plot. Is this fine till now? No questions? Then we can break here.
So one question, like each plot has its own significance, right? Exactly, we have to for a linear we have to use a line plot kind of things, right?
Correct. Right.
Histogram we have to use in one place, and bar where exactly we are going to use bar and all.
When you have the counts defined, you use bar. When you don't have the count, you use histogram. Okay. See, this
And
is just to this is why we are using data visualization. Again, have the concept clear. This is nothing but showing a showing the data in a graphical way, right? So if you tell this data to the clients, it will be hard for them to understand, and for you also, you would need to read this carefully and all, because in real world data set only five, you have already seen 300 rows, right? But in real world data set you will have 1 lakh of 1 lakh or 2 lakh rows of data. That will be pretty much on the cards. Okay. And me and you don't have the infrastructure to run that, so we are limiting to small examples. So in that case, when you are going to find out all these insights by manually checking, it will be impossible. So that's why this plots. So you need to understand the scenario and you need to apply it. Okay, so that's how. So let's get started. So if you see this box plot, right, box plot contains the quartile information of a data set. Okay, this is the statistical plot that we use heavily. So this below line will be your Q0 and the top line will be Q4. In between, this will be your mean, that is Q2. This will be Q1. This will be Q3. Okay, 4 lines will be there. Now this is how this data will look like. Now how do we calculate those Q1 Q2s? Okay, I have considered this data set and I have calculated all those calculations. I have done all those calculations in my Word doc. Okay, in Word doc we have all these calculations. So what we are doing, we are just having the equation. We are just sorting the array. So if you sort the array that is given, you will get this kind of an array. Okay, this array you will get this one. Okay. So next, what we are doing, what we are doing is we are finding out the second quarter. We are finding out the mean of this. So how do we find out mean? What are the number of points? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we have even number of points. What is the definition of mean? Mean is the middle point of the data set to which all the left values will be less than to that mean, and in the right side we will have greater than or equal to the mean, right? So we have taken, and for odd even number of values we take the middle two values. So we have taken these two values, we found out their average and we found 20, and 20 is our mean. Okay, 20 is our mean, and this 20 is referred to as second quartile also. Okay, now so this is the mean. Okay, so here we split the data set. Okay, here in this 20 point we split the data set. Now as we have two middle points of the data, so 2 point we can consider in the for two parts. First let us take this part. Okay, let us take part from this to this 20 and part from this to this 20. Let us take this two part. Now this is already sorted, so we will again calculate their mean. So here if you see 5 number of data points are there, so that means odd number of data. So we will have the midpoint, that is 10 as our quartile, so 10 as our mean. So this mean is called as q1. Okay, this is the first quartile. Okay, from 20 to 70 we have 30, this is called q3, third quartile. So what this does, this gives you this three q1, q2, q3 informations. And if you see q0, q0 is the minimum number and q4 is the maximum number. Okay, q4 is the maximum number. These two are first and fourth quartiles. Okay, so 0th can we say 0, so that is our first quartile, second, third, fourth and fifth quartile. So we have 5 quartiles. So we generally consider this for q0 to q3, q4 is the last one, so we don't really consider this as a quartile, but you can tell it like that. So this information will be pasted in the box plot. Okay, this information will be provided in the box plot that we have in here. Okay, that we have in here. So if you see carefully, for the first, this total, this is the box plot for that. What was the minimum value? 1, correct? So here is it is 1. What was the first quartile? 10. What was the mean? 20. What was the third quartile? 30. And this sums it up. Okay, this 30 sums it up. So this is the box plot, this much you focus on. And the max point, that is what I was referring to as q4, that is not there, that doesn't present, that is not present anyways. So here it is. Okay, how this height is defined: from 10 to 30, how many points are there? 6 points. So that's why this box is a bit bigger. Okay, that box is a bit bigger. So this, the height of is it's almost 6. So that is what this height denotes. Okay, from 20 to 30, how many values, like that. Okay, so that's what is this height about. Okay, that's what is this height about, or you can say it like q1 and q3, in between this height is given. Okay, so this box means here the maximum number of data point are concentrated in here. So between 10 and 20, how many points are there? If you check, so we have 2 10s and 3 20s. So in a data set of 10, we have 5 values within 10 to 20, right? Within 10 to 20. So that kind of information you can get from there. Okay, that you can get from this box plot. So it basically shows you again the distribution of the data and the basic statistics of the data, the quartile range, and how and where and which part of the data, is concentrated. Where the data is more concentrated. Okay, the height of the box is how many points are there, like that. So 10 to 20 or 10 to 30, we have 7 8 data points, so the box is a bit bigger, like that. And from 0 to 10, we have 3 data, so that is the height. Okay, it won't match with the graph, it is just for visualization purpose, it won't match with the graph height. I am just telling you for ease of your understanding. Correct, that is IQR actually. So IQR is, this is between Q0 Q1, this is between Q1 Q2, this is between Q2 Q3. Okay, so that is what is the frequency of the data, right? So that's why we calculate IQR. IQR is to give you a rough idea about how the data is, what is the frequency of the data, how it is spread in a in a range, right? So that's how this works. This won't match with the box line. So this, but big lines are IQR, interquartile range, and how many data sets are there, like that. So that's what is about this box plot. So here we haven't done many things. We have taken 3 distinct lists. We have taken all those into a single list, and we have plotted the data sets, and we have plotted that using box plot. Okay, that is the command for that. We have told it to show the means. We have passed in that show means to be true, so that's why that orange dots are shown. Okay, those are the means actually. So that's how this box plot works, and that's what kind of information you get from this box plot. Okay, that's what kind of information you get from the box plot. So this is what is about this box plot. Others I have already explained, so not repeating those things. And if you go on this code perspective, we have taken 3 different lists of total, order and discount, and we have combined all those 3 lists into one using this list command, and we have passed 3 separate lists to plot it. This is just to have the information handy, because this is just to follow the syntax of the box plot, because it takes in the entire data set and it will create 3 boxes for 3 different data sets that it has. Okay, so that's how this box plot works, and that's what kind of information we do have from this box plot. And generally speaking, when you start analyzing data, you will use this box plot to quite some time. Okay, to check the data distribution and to check the quartile range, to check how it is distributed among the quartiles and like that. Okay, okay, so that's what it is. Okay, see, don't think about the height much. So that height is basically the IQR, that is the distance between q0 q1, and that shows how many data points can be there. Okay, so that's what is this height reflects. Okay, height doesn't have much of an scenario here. So this is just to connect the plot and show it like a box. That's why the heights are there. And the distance between two quartiles are called IQR, that is interquartile ranges. Okay, so the the value of the height is interquartile range. So I mean, that is the frequency of the data set. Okay, what does that mean? So say 0 is the minimum value and 10 is the first quartile. So if you check the quartile range for the first quartile, that is 10, right? So the height equals 10. Okay, the mean is 20 and the q3 is 30. So what is that quartile? That is like 10, right? So that's how this height is there. That is the interquartile range actually. Okay, so that's how it works.
And 70 is outliner. It will exclude that while calculating.
No, it has calculated that, but that is the max value, so that's why it has kept it that far. Okay, that is the max value. But for quartile calculation, we don't take into account the max value. Okay, so that's why it is left out. That is a max value, right? We don't take it into account like that.
So why we don't take into the account? Because it's far away or something like that.
No, because that is what the value of because that is how we calculate the quartiles, and that is what is the IQs are all about. Okay, we don't take the last one. We have only 4 quartiles, q0 to q3. Q4 is not taken into account, so that is the max value basically. So that is not taken into account. That is not outlier. That is how stats work.
Okay, okay.
Okay, so any questions? Okay, so next one is violin plot. It is the same as this box plot, but it is different. It has the same values. Okay, q0, q1, q2, mean, and all those kind of things it has. But what you see here is a violin kind of a shape for all this distribution, right? So that shape that you see, the shaded area that you see outside the middle line, that is the probability density function of the data set. Okay, that is the probability density function of the data set. What does that mean? Okay, what does that mean? So okay, what does that mean? This shaded area. Okay, this shaded area. So this is the probability density function. That means probability of having a number between. So what is probability density function? Probability density function means the probability of a point being in a range, or a probability of an event being occurring, right? So let's say we have a range of 0 to 10. What is the probability that in for a particular data set, what is the probability that number 4 will occur? What is the probability of number 4 will be there in the data set? That is what probability density function calculates. Okay, so that means this is the probability of an event being happening in a sample space. You can, if I go by the by default stats terms, that is how it looks like. Probability of some event happening in a sample space. So that is what it defines in probability density function, and the same thing reflects in violin plot. So how can you use it? Similarly, as I show you the calculation for q1, q2, q0 to q3, same lines are there. See, only 4 lines will be in here, right? If you see, there are 4 lines, so those lines are for q0 to q4, like that. And then the outside shade is the probability density function. So how can you see, what can you configure from those? Between 1 and 20, how many values are there? If you check the data set carefully, there are 5 to 6 values. between 1 and 20. So that's why the curve is thickest at that point, right? So there is a high chance that if any future data comes in, so it will be in that range. So basically you need to think it in a bit other ways. So this static data set won't explain you. So let's say you have built a model. Okay, you have built a model based on some features. Okay, what is model and all, don't go too deep. Model is an algorithm, okay, that we will discuss in the next class. So how I am trying to explain when you use it and how you use it. So let's say you have built a model without seeing anything. You have put in some features, you have taken into you have assigned the features into the weight to the features. So now how do you validate that? So if some feature values are in between, lying heavily between 0 and 20 or 30, then that means when you get a test data set from that of the same pattern, it will always follow that probability density function. So that way you can understand which feature to have what kind of a weight. Okay, so and which feature is having what kind of a distribution. So these things you can check. So that won't be only a single feature, that will apply for all the features. That is a machine learning data set that you will have. So this applies to all those. For ease of understanding, I explained with one, because there is only single arrays are taken into account. So this we will plot for all the features, and we will see how the data is being differing. Okay, what is the probability that in future we can have different set of data. So if we have some true false kind of skewed data set, we will have it often. So 0 and 1 kind of data set if we have, then probability density function will have two peaks, one near 0, one near 1. Okay, so that's how it will look like. So let me try and show you. 10 points we have, right? 4, 5, 6, 7, 8, 9, 10. See here, because this is not visible, because this is having this large values. So this value, if you enlarge it, you will see that this is stacked between 0 and 1 only, right? So you will see two peaks in here between 0 and 1. So that's how this thing works. So let me try this. See, you have two peaks, right, between 0 and 1. So as we have more ones, so the peak is flattened near 1. As we have less number of zeros, so it is flattened near 0. But see, between 0 and 1, the curve is getting shortened, and when it goes uh, so 0.6 will be their mean. Okay, because that is what we have taken as 0 and 1. Okay, so 0.6 will be their mean. And if you see from 0 to 0.6, that the curve is a, so let's say 0 to 0.4, the curve is wide enough, right? Because till 0.5 we can consider it to be 0. So from 0.4 onwards it started to increase, because if it is greater than 0.5 we can estimate it as 1, right? So and at the 1 it has the maximum width, and at 0 it has a maximum width. Others are just shortened, right? So that's how probability distribution function you can use. So here what you can see, this is a skewed data set, right? This is a skewed data set, so this cannot fit a straight line equation or something like that. So you need to change it, you need to change the thinking, and you need to choose, explore other options. So that's how you can check that. Yes, this is a binomial function. So this is a skewed function. It will be of form e to the power x, right? E to the power x by 1 plus e to the power x. That is sigmoid function. Like that we will have this. Okay, this function will output two values only, 0 and 1. So that's how it works. Okay, so that's how violin plot works. So if this is clear, we will just I don't have examples for this because we won't need that. I will just explain these three plots actually. We won't need that much, so I will explain what are those and how they are used, like that. Okay, next is this quiver and stream plot and area plot. These three we are not gonna use much. I will start with area plot. What is area plot? Area plot will show you the area covered in a line. So how you can see that? You can check like this. So let's say we have a line plot. Okay, we have a line plot. I am drawing some line over here. So let's say we have a line plot like this. So let's say this is the line plot. So area plot, what it will show? It will show this area. So it will show this area that we have inside this. Okay, that is the area plot. So that is to show you the area covered by a curve. Okay, area covered by some curve that we have. So that is what is called area plot. Okay, that is what is called area plot. Now if I show you here, like this is the quiver plot, right? So if you see all these individual data points, right, these individual data points are looking like vectors. It has some directions, right? So that is for basically magnetic field analytics and high end physics needs. These are basically vectors. These are basically directed vectors. This is basically needed by physicians. Okay, this is basically needed by physicians, these two plots, this stream plot, this one up here and this one down here. These two things are basically required by physicists to analyze the vector and to do vector analysis. Here if you see, this has pointed ends, right? So that is the direction of the vectors that goes in or out. So electrical engineers or physicists can use this plot. So if an electrical engineer is there in class, you will understand this, right? Current inflow, outflow and all those kind of stuff. So if you have a large circuit, it will something look like this, right? So if you have a midpoint in here, what is the current input, what is the current output, and all those blah blah stuffs of electrical things will be there. So that's how this quiver plots are used. That's how the stream plots are used also. In stream plots, what is the stream plot? What is the difference? The difference is in the stream plot, we won't have that vector direction. We will just have positive or negative value for a vector, and that will be just a representation of the vectors in a 2D plane. Okay, so that's how this quiver and stream plot works. An area plot shows you the area covered under a curve. So these three plots, data scientists are rarely uses. Even if you use area plot somewhere, some down the line, but quiver and stream, let me assure you, you won't use it ever. Okay, because we are not gonna deal with vectors, right? That's how. Okay, so any questions on these three plots? So before that, I will just quickly go through these points. I have told you, but still, see here, where is bar plot used? So bar chart or graph chart is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values they represent, right? That's what. So the bars can be plotted vertically or horizontally. So what is categorical data? When you have count kind of thing, when you have some categorical data means where we have categories defined, right? So here apple, oranges and all those kind of stuff and related to their counts or their price or their anything. So these type of data are called categorical data. So then we do use bar plot. Okay, for scatter plot, where is it? Yeah, scatter plots are used to plot data points on a horizontal and vertical axis in attempt to show how much one variable is affected by another. That is what is the distribution of the data set, right? What is the distribution of the data points in a 2D plane, right? How the data are distributed. So if the data are very closely stacked, that means x and y values are very closely related. So we will have a high correlation. If they are widespread, then we will have a low correlation, right? Because they will be independent. If you see very high what sorry, so if you have a very the high difference between two data points, so that means if the difference is more, that means the correlation is low and they are independent kind of thing, right? Because in those two, if x and y has a pattern, then they will be following a pattern, right? Either they will be clustered, either they will be having a linear equation like that. Okay, so that's what it helps you to understand. And in a cluster, all the values will be tightly correlated. So if you try and find out a cluster here, you will see one, then two, then three, then four clusters, right? Like that. So you will see four clusters are there. So they are not tightly coupled. But if you see in a cluster, this three or four data set, they are almost following a line, right? These two are following a line. So that kind of values you can get from scatter plot. I have told this, but it is written beautifully here. So that's why just covering it. The sentencing are good here. That's why. Okay, histogram I explained. So plot used to display frequency across a continuous or discrete variable that I already discussed, right? Box and violin also viewing summary statistics, and is an efficient way. Also boxplot helps you in doing outlier analysis. So these are outliers, right? This is the outlier because you see the quartile range finishes here and some value is up way there. So these are outliers, right? These are the max values. These are way far high than outlier than the Q3. So that means almost all the data sets lies between this, but this data lies far above that. So this is an outlier, right? That's why it is left out. That's why it is left out. And if it is not an outlier, it will be close to the line, right? If the value is not an outlier, it will be close to the line. So that way we will see. But again, that won't be plotted using dot, because the max will be plotted using dot here. Let's say we have a value of 35, so it will be somewhere around here. So that we can't consider as outlier, right? Because it is pretty close to the Q3 range, right? So that is there, that value is there. So that's how we can use box plot. Violin also same thing, except that we will have a probability distribution function attached to it. Okay. Okay, so that's how we have image plot. Let's leave it. Let's not show. Let's not go into a bit detail. So just know how to do that. If you open a image, okay. So how you can do it? You have image processing library called Pillow inside Python. Okay, you have Pillow library in Python. You can install it. No need to do it. Okay, no need to do it or remember it. This won't be used. So using Pillow library, you can use this image function and you can open an image. All images are what? Arrays, right? They are arrays of pixels. So you can convert it to a numpy array. You can pass that numpy, you can plot that numpy array itself, and that would serve your purpose, right? That will serve your purpose. So this is what ax1.imshow. Imshow is for showing the image. That is again a matplotlib function. And if you pass in the array, the corresponding values will be shown as a image here. Okay, the corresponding values of the pixels will be shown as an image in the output plot. Okay, so that's what is image plot. And the image plot to histogram also you can do. So that way you will see the distribution of the like that distribution of the colors in that, right? Colors or pixels in that. So see here, this is at 250. This is a very high value, so it might be some pixel having high value, because see, blue is having a pretty dominant color here. Blue is pretty dominant, right? So that's why it might be causing this high value kind of thing, right? So that's how is for image plot. That is not at all used. Quiver's theme, as I already told, the example is not much required. See here, this is a plotting a vector. How can you do? You can do it using quiver, this quiver option. Okay, this quiver option, we have created a subplot, then we have created this quiver option. Okay, using this quiver, if you pass x position, y position, and the directions, so you know, right, the vectors will have two directions, 1 0 1 minus 1. This is the direction of the vector. So it will go from 0 to 1 upwards, and this will go from 1 to minus 1, that is in a downward way. So that's how the vector directions work, and that's how the vector calculations work. That's how you can plot a vector. Okay, you're using quiver plot. So this is a 2D plot. This is a stream plot actually. So stream plot is used for vector calculation, vector algebra, vector physics. I mean, wherever you have a vector involved in physics, electromagnetics, electrical engineering, stream analysis like cyclone analysis, wind trend prediction, like those kind of scenarios, you will have the stream plots into account. Okay, so this is just a bit different from the vector plot. And here also you have the same thing, the stream plot function. Okay, but you won't be, you will use it pretty less. Okay, see here, this is a trend analysis, a wind trend analysis kind of thing. Okay, so that's how this stream plot works. So see, the pie chart is to show you percentage or proportional data. Okay, so this can be this can come handy when you have more than 4 or 5 categories. Then box plot will take up a lot of space, and from the box plots also you will only see the values, right? The counts and the categorical values like that, but you won't see the percentage of the data that is being placed in those each of the categories. So those kind of scenarios pie plot comes into picture. Okay, I will show you the coding example for this pie chart. Okay, right? It's not much left for pie chart to be customized. So let's see. So if you see, so now it will be easier for you to understand all these functions. So first what we have done, we have taken a label array of 4 and size array of 4. So that denotes in a data set what is the what are the number of dog, cats, wolves and lions that we have. Okay, so if I show you a quick math, that then it will be easier. So let's say what are the values that we have. We have 50, 45, 60 and 80, right? We have 50, 45, 60, 80. So how it calculates? So 50, 45, 60 and 80. So it comes to 140, it comes to 95, this two comes to 275, right? So we have total of 275. Now if you calculate 50 by 275, how much it comes? It comes to 10 by 52. So that is somewhere around 20%, right? If you calculate this, it is somewhere around 20 or 19%, right? 50 is the count of dog. What is the percentage of dog? Percentage of dog is 21.3%, right? So this kind of percentages are calculated and shown over here. Okay, for cat it is 45, so it will be around 90% like that. Okay, so that's what kind of information you can get from this pie chart. Okay, now how do you plot that pie chart? You need to use plt.py function. Within py, if you provide some, and the options I will explain now. So sizes is one variable, labels is another variable. So labels we need to pass it, because otherwise this labels of lion, dog, cat wolf won't be shown. So and it will be equally, it need to be in the same order as the size array. Okay, otherwise the this labels will be misplaced. Okay, next is auto pct percentage 1.1 f percentage. That means what is the display percentage, what will be the format of it. So we want only one decimal after the we want only 1 point after the decimal, right? So that's why we have given 1.1. So that is the number will be whole intact, then after the decimal we want only 1 point. So that's why 1.1. Shadow true means you see there is a shadow effect inside. If you give it as false, I will show you, then you will understand the difference between these two, shadow true and false. So if it's a if it's a 3D plot, I mean if so here the shadow is not really visible, but it should be if you use lighter colors. Okay, lighter colors will have you the shadow visible, so it will have a bulging effect actually. So that's how it will look. So that is not much used, you can leave it. Okay, start angle is 90, means then the angle will be 90-degree angled. Okay, so it will have a equal kind of a shape, so it will have a equal kind of a array actually, I mean sorry, equal kind of a shape of the circle. So that's why start angle equals 90. Explode, as you can see, if you mention 0.1 as an explode, then it will be those slices will be cut out from the array and it will be outside the array. So that's how explode function works. And explode you need to give one for each. So where I have mentioned 0.1, those slices, see, they are cut out from the pie chart, right? That's how this pie chart works. Okay, so pie and donut I will finish it, then I will open for question here. So donut chart is the same thing, just the difference is it shows the area. Instead of showing the percentage, it shows the area. Okay, for that what we do, we create two pie charts and we combine those. Okay, so see here, we create one pie chart here. This pie chart, if I show you one by one, so this is a pie chart, right? We don't have the numbers mentioned, so we haven't mentioned auto PCT, so it haven't shown. We haven't mentioned shadow, so this kind of effect is not there. If you see these two, a difference between these two, you will understand what is the difference of the shadow function, right? So this is a pie chart. Okay, we have created a pie chart using this variable that we have. And okay, this is color white, let me make it black. Black is coming as blue. Why? Okay, black, only one body takes, that's why it's taken blue. Okay, got it. So that's how it will take only one word in the color, so that's why it is taken as black. If I put O is not supported. Y is supported. Okay, so Y for yellow. So you see here we have a yellow kind of a circle. So this circle is to give the blank inner filling. Now if I run this first pie and second pie together, see this effect we want to give, right? So this is a pie chart that is there. So if you remove this second pie chart, what happens? This is the entire chart, correct? This is the entire chart, correct? What is the radius of this? 1.5, right? Now we want to show it as a donut. So what we can do, we can cut out some area, right? So that without saying, if I draw it, it will be easier. So being said that, so let's say this is a bigger circle. Okay, let me change the color. So let's say we have blue here. So this is a bigger circle and we have these three parts. Okay, we have these three parts. Okay, let me change the color again. Let's say I'm taking green. So this part is green. So next I'm changing it. This part is pink. Let's say like that. Okay, and this part is orange. This is filled up. Okay, this is entirely filled up. I am not going to fill it up. So what you can do, you want to show only this much. Let's say only this much you want to show. Oops, sorry. Let me change the pen color. It will be easier for you to understand. I have used exhausted all the colors now. Let me show. Let me just think. We want to show to the viewer this much of value, this much of portion. So what can we do? We can fill it up with some value. We can fill it up with some color. Let's say we are filling this up with orange. Okay, what will happen? This shade will left upon, right? This outer side circle will be left upon. So that's how you can create a donut chart. It is not an option in it. So let's say if I increase this, you will see the donut chart gets shrinked. Okay, the donut chart will get shrink. That's why we have used white here, and that's how it works. Okay, if you use 1.5, the donut chart will vanish and it will have a slight effect over there, right? If you use 1.3, it will be pretty thin, right? So that's how you can create a donut chart in Matplotlib. Okay, that's how you can create a donut chart in Matplotlib. The pie chart you will create and you will empty its center. That's how you can create it. Okay, so two pie charts combined together will give you a donut chart. Okay, so that's how this works. Okay, so for your ease of understanding, I will leave it as yellow only, so that it's better for you to understand how you create donut chart. There is no donut chart, you are fooling the audience. Okay, so next is area chart. So area for area chart I have already shown in the last class, right? So what you can do, you can use stack plot function, and if you pass two variables, then it will show you the variable the plot covered. So let me show you using a line equation. Okay, oops, sorry. Let me copy the line equation that we had earlier. Which one? L. Yeah. So that's how this will work. Okay. That's how this will work. So for this color, if you write black, it won't work. But if you do color, it will work. Yeah. So that's how it works. Okay. So see now we have, let's not give it green. Let's give it maroon. Let's give it green. So if you increase the transparency, it will be easier for you to show. Yeah, looks nice. So that's how this stack plot works. So see, this is basically denotes the area covered between a curve. Okay, a curve or a straight line or whatever is it. Okay, so that's how this stack plot works. So stack plot is basically for showing you the area. Okay, the area of the plot covered. Okay, so that is how we have this area plot. So this area plot you might use somewhere, but not much used at all. But this quiver and stream you won't use. Pie donut you will use often. If you have some presentations, you will use this. And without from now on, what I can suggest you, if you are working on some data on Excel and generating some graph on Excel, try to switch to this one, right? Try to switch to this editor like this, like Python. Okay, so just try to switch to Python, and then you will have nice looking charts, nice looking things, and you will learn this Matplotlib library in a vast details. So that will help you. I believe whoever is there, everyone is working on this Excel heavily, so you can try it. Okay, you can try Python for generating those charts also, so that way you will learn it. Okay, you will learn it quite well. So that's how we have. So that is what we have theory portion for this charts and all. Okay, so that's how we have. So if nothing, then let's go for the quiz. So let's go through this quiz. We are plotting a line plot between two variables a and b to add a legend. Which will be the following option we need to use. Which one? Can anyone give it a try?
A quick info guys, if you want to master data visualization using Python, please check out the data science using Python certification course offered by Intellipaat. You can find the link mentioned in the description. This brings us to the end of the session. I hope this video was informative. If you have any queries, please comment below so that we can get back to you as soon as possible. Thank you for watching.